Well, I've always wanted to say this. Welcome to my TED Talk. Um, so today I wanted to talk about how to manage knowledge in the post-pandemic world. I know it's a very cliched term, post-pandemic. A lot of people are using it. But it's a really interesting kind of space we are in today. This is a study that was kind of reading through recently, that the knowledge worker shortage today is one of the greatest that we have ever seen since 2008. If you look at the statistics in the energy sector, it's about, at the end of the last year, it was about like 3.5% or so turnover, which is one of the higher ones in the industrial sector. But if you double click into that 3.5% number and you look at just the knowledge workers, which are essentially people who are working or generating data or analyzing data, that number is about 10%. It's really high when you look at that number. So that's kind of what we wanted to look at, is like, how do we address that knowledge worker shortage? And with that statistic in mind, one thing that our hypothesis is that companies, the biggest asset that they have today is the knowledge that is stored in all the experts' mind that they have within the company and all the content that they have created over the years. Right? That's kind of our hypothesis, is like, that is the biggest thing that is driving the success for a company in the long run, is all the expertise that has been created and been kind of curated within the organization. Now, with that in mind, kind of what ends up happening is when these experts, they move or they retire or they resign, the people who depend on them, they are essentially left to fend for themselves, and they're often left in the darkness, right? And people will, when they're exiting, they'll turn in their laptop, but the information on their C drive is pretty much useless at this point. Nobody knows what is in there, and the laptop is taken, but most of the time is wiped clean, or that information is copied somewhere, but it's not really utilized. So the people who were essentially depending on that expert, they have to now go figure out how to find that information. And that leaves a lot of those people to kind of scramble for information and not know where to find it or how to look up that specific piece of info. Now, this is where we can introduce one framework, and this is a really kind of interesting way to kind of put it on an XY chart. That's how kind of we easily understand stuff. So you can kind of think about it in two axes. So the Y-axis is how well is it understood, and the X-axis is how many people know about it, right? So let's assume on the Y-axis, like, the expert knows at the very bottom, but they can't really explain it. They know it, intrinsically know it, but they can't explain it to other people. In the middle is everybody knows it, but can't really explain it. And at the very top is everybody knows it and they can explain it, right? So that's kind of, you can think about the Y-axis. And the X-axis is only one person knows about it, everybody in the company knows about it, and everybody in the industry knows about it. So just think about that, and then you can kind of take your knowledge assets that you have in the company, and by knowledge assets could be a class of information that you're kind of thinking about, and you can plot that on that XY chart. So I'll give you an example, like things like these 4 documents or these 4 classes will fall into those kind of spaces. Like on the very bottom left could be an implicit knowledge that a subject matter expert has about a certain topic. They know it, they internalize it, but it's kind of hard for them to explain because they often make decisions out of instinct. On the very right could be industry regulations. On the top right could be software manual. Everybody knows it's easily available on your website. So you can probably tell from this graph that the stuff that's on the very bottom left, like the southwest corner, is the hardest to access. And the stuff that is on the top right corner, that's the easiest to access. So the goal is that you have to move stuff from the bottom left to the top right, right? So that should be the ideal way that you want to kind of have knowledge kind of move around in the organization. But how do you do that? So our theory is that you can do it in 2 ways, and both have to happen at the same time. To move stuff to the top, you got to codify any kind of tacit knowledge that you have within the company. And by tacit, I mean stuff that people know it is implicit but hasn't been documented yet, or is being documented but not well understood. And then on the bottom, to move stuff to the right, you got to distribute that knowledge somehow so that anybody, when they need it, can access it, and they don't have to depend on anybody else to go find that information. So those are the kind of 2 pathways that you have to take to move any kind of information around. Now, our hypothesis is that you can do it in 2 ways. One is to codify tacit knowledge. You can use NLP. is one of the branches of artificial intelligence. And then on the very bottom, to distribute that, you can use search or information retrieval to make that available for everybody. So how do you do that? So that's kind of what we wanted to talk about, is how do you use NLP and search to codify and to distribute. But there are a couple of hurdles. Before we start talking technology, there are a couple of things that we have to kind of consider. The first is that expert knowledge isn't stored in one place. Nobody's writing down stuff in one wiki page or in one Google Doc, right? It's kind of all over the place within the organization. It's in Outlook, it's in Notion, it's in Wiki, it's in Confluence, Google Drive, SharePoint, all over the place, right? So it's spread across multiple platforms. And oftentimes you have to kind of jump between all of these to find the info that you're looking for. So that's the first hurdle. The second is that we are in a complex industry. So the stuff that is written in these sources are just written in English. There's a lot of complex domain jargon in there. There's a lot of company lingo in there. There's acronyms. There's things like that that are mentioned. So to understand that doesn't just take a natural language processing model that just understands the general world. You have to understand the industry. So that's the second hurdle. And the third, and this is really interesting, is that documented knowledge is often incomplete. And companies don't know what they have. They often don't know what they have, so it's virtually impossible for them to know what they don't have. And the gaps are often discovered only after mistakes are made. So those are the three things that we have to deal with. Now, kind of keeping this in mind, let's see how technology can help us solve this. So I want to talk about four things, and kind of this is where we start diving into specifics of natural language processing, is how do you build a language model? How do you develop symbolic knowledge? I'm going to talk about why that is important. How do you identify gaps that are in your knowledge? And then how do you fill that and put it all together? So what is natural language? What is language model? So a language model is a way you can train a machine to understand what is that your content is all about. So it's kind of like, just like English, when I'm talking to you, you understand what I mean, a machine has to understand what I'm saying. So that's the part where language model comes in. So why is language model important? Because a machine doesn't understand words. You have to somehow translate those words into numbers. Machines understand numbers. So if you look at this sequence, if I ask you what comes next, you can actually teach a machine to predict what comes next. It'll guess 9.2, and you're like, no, you're a little bit low, go high. It'll guess 10.5, you're like, oh, a little high, come low. It'll eventually guess and get to 10, which is the correct answer. Now, when it comes to words, it's slightly harder because words don't follow any set sequence. Like if I'm putting the sentence and I ask you to finish that last word, there could be a lot of words that can go in. If you go down a dictionary, you'll probably pick these words like ride, rigs, rigatoni, right? But rigs is the right word. But when a machine guesses rigatoni, how do you tell it that you're far away or you're close? What defines that closeness? That's the part where a language model is helpful. It's nothing but a probabilistic model that can tell you the probability of two words or two sentences occurring close to each other, right? Now, they have to follow three rules. So those are the three constraints that a language model has to kind of follow. One, it has to be contextually close. Like for instance, if you look the words in pink, like driller, rigs, oil, Permian, Texas, they all have some kind of similarity, you know that. And the reason they're similar because they kind of occur with each other in any text that you read. Things like Gulf Coast and Houston, they're closer to each other. They're close to Texas, but they're not so much close to driller. And things like SP and Energy Dot, they're close to Gulf Coast because that's where we are at, but they're not so much close to oil or driller, right? So they're further away. So they have to be close to each other contextually, but they have to be far apart when the context kind of moves away. They have to be mathematically true. So they have to kind of add up. So you can see like here, Texas minus Austin plus Colorado has to be Denver because one is the capital of other. So this also has to be true. And the third thing, and this is really important, it has to be domain aware. Because in the geology domain, things like bank and river are close to each other, but the word loan is far away because geology doesn't care about a bank and a loan. But in the finance domain, it has to swap positions. A bank and loan have to be close to each other, but river can be far away. So these are the things that you have to work around when you're building a language model. And what does it help us do is when you're training the model and you ask a question about driller, it knows that it also has to look up rigs, or it has to also look up oil. Or when you're trying to predict something in a sentence, it can predict those words very accurately. So those are some of the applications of a language model. Now, how do you build one? The architecture is pretty straightforward, actually. You take a huge corpus of text that you have, and you give some sort of a machine learning model. It could be a neural net, or it could be a deep learning model. You give it words, and you teach it to predict the next word in the sentence. Or you give it a sentence, and you teach it to predict the next sentence in the paragraph. And the machine learning model will eventually figure it out once given enough corpus of data, what is the parameters that it has to tune to make that prediction. I'm sure you've heard of BERT, you've heard of GPT-3. Those are big language models that have been created with huge corpus of data to build something like this. There's other ones like Word2Vec that came out of Google that can actually do this. So that's the first part. You have the language model built out that can predict words that occur with each other. Now, there's certain scenarios where language model fail or they kind of stop working. There's a limit to it. That's where symbolic knowledge comes in. Take these two questions. Think about it for a second and see if you can tell the difference between the two. The answer for both of those questions is the same. It's Satya Nadella is the answer, but how do you get to that answer is different. Because in the first case, a language model can read a sentence and then say, okay, Satya Nadella, CEO in Microsoft, they occur with each other very commonly in a sentence, so most likely I can guess that's the answer. But in the next one, you can't guess that because you have to make an inference first to get to Bill Gates, to get to Microsoft, and then to get to Satya Nadella. So that's where symbolic knowledge comes in. So to develop symbolic knowledge, you have to actually create something called an ontology or a taxonomy that can tell you the relationship between different entities. So for instance, Microsoft was founded by Bill Gates. Bill Gates is an ex-spouse of Melinda Gates. And then you can hop that connection to get to the answer. Similarly, in the energy sector, oil and gas, you can make connections like this. H2S causes corrosion, or oil and gas, oil, water, gas is a part of production. So you can make these connections. Typically, ontologies are handcrafted. People will sit down with an expert within the company, an ontologist will sit down and they're going to codify this. It takes months, 6 months to a year to build up an ontology. Now, there are parts of NLP that make this process more automated. So you can take like a 1,000-page book and you can turn that into an ontology in about 4 hours or so. Now, this is a true example. We actually took like the Harry Potter books, passed it through the ontology, and you can create almost like a network of like all the characters, how they interact with each other, what is the relationship between them, who is a parent of who is a friend of who. So you can create this ontology like in a matter of like just an hours. It's not as high quality as somebody sitting down and doing it, but it is a really good first pass at creating something like this. So that's how you can build symbolic logic. It can pick up patterns and kind of create those network of relationships that you can use in answering questions. Now, the third part is identifying gaps. Like, how do you identify what you do not have? And the way you can do that, one way, is by actually using those ontologies. Now, take, for example, this thing over here that carbon dioxide and methane, they're both greenhouse gases. Let's say you see that in that symbolic knowledge. And you see two paragraphs, one about CO2 and one about methane written in there. You try and determine what kind of questions are being answered by those two paragraphs. And you notice that there is a disbalance between the two. The first paragraph is answering two questions about CO2, but it's not answering one question about methane, even though they're both equivalent. So you can kind of detect gaps. You can see that, okay, I have content for both, but this question is not being answered, and this other question about methane is not being answered. So you can, by looking at that disbalance, you can kind of go back to your experts and say, hey, could you answer this question? Because if you don't, we will have this gap in knowledge that is not filled. And if somebody asks me a question, like how much is the energy needed for CO2 mitigation, I won't be able to answer this, even though I know you know this answer for methane. So this could be a way to identify knowledge gaps by looking at that symbolic knowledge that you build, looking for that unbalance or disbalance, and then try to kind of balance it out. Now, how do you put this all together? So a technology like my startup, Nesh, we do something like this. What we do is we connect to all of that content that we have within the organization, no matter where it sits. It could be in SharePoint, Confluence, Box, Salesforce, wherever. We put it all together. We unpack all the domain concepts that are written in that content. We then connect with the experts to fill those gaps. And then Nesh becomes this subject matter avatar that you can ask questions to, so that the reliance on the expert is a little bit reduced, their workload is reduced, and then the risk of if you lose them in the future, that is also reduced. So that's the idea, is you can put it all together, but all of those individual pieces have to exist for this to all come together. Now, there's a lot of different applications within a company where this could be applied. So where do you start? There's a lot of different areas. There's so much knowledge within an organization that is quite large. So where do you begin with? Now, we have identified kind of 5 different areas where a technology like this could be applied. And the reason is because these are the ones which are critical and revenue driving. So one is customer self-service. So a customer comes to your website and they want to know what you do. They want to ask a question and they want to get back an answer. And so you can deploy an avatar that can understand all the content that is customer facing. So it could be like tickets, it could be FAQs, it could be the content that is on your website. And a person doesn't have to navigate the entire website to figure out if this is what you do or not. They can just ask a question, get back an answer. Sales, another area. Salespeople have so much relationship, they have created so much content over the years, and if they walk out the door, then you lose all of that context. So you can train your language model to look at CRMs. You can train it to look at all the PowerPoints and decks that they have built over the years, and you can get answers out of it. Product development is another area. Say you're a product manager, you're often kind of asked questions by the people who are working in the development side, or you're often asked questions by the executives. You can put all your R&D information, you can put all the marketing information, you can put all the kind of tickets that you're working on, and let the language model kind of read it, understand it, and then those people won't have to bug you all the time. They can ask those questions. And then even you as a product manager can look at patent information or R&D stuff and then get your own answers. Standards, policies, and procedures is another big one, especially for financial institutions or highly regulated industries who are looking at what kind of policies or standards do I have to look at when I'm making a decision. Very long documents you have to read through, highly nuanced information. So you can let that NLP model kind of find those answers for you and connect the dots. And another one is lessons learned. So you're working on a project, you know something similar has been done in the past. There have been learnings, you don't want to reinvent the wheel. So how can you do that? By looking at all the lessons learned that others have gone through, so you can kind of learn from their battle scars and not have to go through that on your own. So those are some of the kind of avatars that we have thought about that could be used by people, because these are revenue driving, high-value use cases. Now, I want to leave you with one last thought. Now, you're probably thinking I really like quotes from consulting firms, but the reason I picked this is because it has a really important statistic in it. And it came out from Deloitte in 2021, was that 75% of companies believe that preserving knowledge is key to their success as they emerge out of the pandemic, but only 9% are prepared for it. Now, Deloitte said in their own words, they've never seen a disparity this big that people want it, they just don't know how to do it. Now, and I think the reason of that gap is because it's such a nebulous topic of knowledge. Where do you begin? Where do you start? How do you start capturing that information? So my hope is that today with this presentation that I give, it gives you some idea of some framework and some technologies that you can explore to start doing this. Because I think in the long run, this is going to be one of the crucial things that you have to do to capture knowledge, so that all the things we talked about this morning with human capital kind of leaving the industry and people moving around, these kind of risks could be mitigated. So that's it. Thank you so much for your time. It's my pleasure kind of introducing you to this topic. I'd love to take any questions that you have.